welcome to Space Repo. All right, today we are digging into something absolutely massive. NASA's secret plan to build a permanent base on the moon. Yeah, you heard that right. And the craziest part? The construction is set to kick off a lot sooner than you probably think. So the big question on everyone's mind is this for real? I mean, we've been talking about this for decades, right? Are we finally going back to the moon to stay? Well, the answer is a huge, definite yes. But the way we're going to do it, well, it's nothing like what we've tried before. Let's get into it. Okay, so first up, why is this time any different? I mean, we've been there, we've planted the flag. What's the big deal now? Well, turns out everything's different. We're talking about a shift from just visiting to actually moving in. And this really breaks it down perfectly. Think about it. Apollo was an incredible sprint, right? The goal was flags and footprints. Get there, plant the flag, grab some rocks, and get home safe. It was a race. But Artemis is a marathon. The goal isn't just to visit, it's to create a sustained presence. We're building a foundation, a launch pad, not just for exploring the moon, but for eventually heading out to Mars. At the very heart of this whole new plan is something called the Artemis Base Camp. Now, this isn't some little temporary tent. We're talking about a full-on planned outpost at the moon's south pole. And you might be asking, why there, of all places? Well, it's because that's where scientists are pretty sure we're going to find the single most important resource for staying there long-term: water ice. Okay, so how in the world do you build a base in one of the most brutal environments we know of? 250,000 miles from home. Well, you don't send people to do the dirty work. At least, not right away. You send in a totally new kind of construction crew.
Yeah, you read that right. This is a complete game changer. The very first builders on the moon, they won't be human. We're talking about all the hard stuff. The digging, the hauling, the basic construction, it's all going to be done by autonomous robots, running on some seriously advanced AI.
And this is just brilliant. It shows exactly how they're pulling this off. Before they even think about tightening a single bolt on a real rover, these machines live, breathe, and work for thousands of hours inside these incredibly realistic computer simulations. Engineers can test everything. They can see how the robots will handle that super fine abrasive moon dust, the regolith that just destroys machinery, and they can train the AI brains that control them, all before spending a dime on physical hardware.
So just how smart are these things? Well, it's actually pretty amazing. Let's break it down. A human, back on Earth or maybe in orbit, gives a simple command like, hey, go drive to that big rock. The AI uses its camera to see the world around it, and it actually understands the words. It connects what it sees to what you said. It figures out, okay, that's the rock, then it dives into its library of skills, picks the right one for the job, and just does it, all by itself.
And this quote from the actual researchers building this stuff really hits the nail on the head. They're not just building a robot and then, slapping an AI on it later. No way. The physical design of the machine and the AI brain are being developed together hand in hand as one single unified system. That's the secret sauce that makes this whole new generation of robots even possible. All right, so we've got the robotic builders. That's the how. But what are they going to build with? You can't just keep launching rockets full of building materials from Earth. I mean, the cost is just astronomical. No, to make a base permanent, you have to learn to live off the land.
This is where a cool concept called in situ resource utilization, or ISRU, comes in. It's a fancy way of saying using what's already there. We're talking about mining that water ice to make breathable air and drinking water, and get this, even rocket fuel. It means pulling metals like iron and aluminum right out of the moon dust to 3D print tools and parts. And of course, setting up a power grid and a communication network, basically building a city from scratch using local materials.
Okay, I know this diagram from DARPA looks pretty complicated, but what it's showing is absolutely revolutionary. This isn't just NASA doing everything by itself. Look closer. You see all these different commercial companies providing services? You've got companies like Blue Origin potentially handling power. And over here you see Nokia is working on the communications grid. It's an entire ecosystem where companies can connect, work together, and even trade services, creating the very first economy that isn't on Earth. And that, right there, is the real game changer. This isn't just about building another government-funded science outpost. This is about planting the seeds for a self-sustaining lunar economy. We're moving away from a model where the government pays for everything to one where commercial companies are both the service providers and the customers. That's why this time is so different. So, we've got the grand vision.
we have the robot construction crew, and we've got the economic blueprint. The big question is, when does all this actually start happening? Well, the countdown is already on, and the first major steps are literally just around the corner.
All right, let's look at the timeline. Things kick off as early as 2025, with robotic missions heading out to survey the sites and start delivering the first pieces of infrastructure. Then the big one, 2027, is when Artemis 3 is scheduled to land, putting human boots back on the lunar surface. But the really crucial year is 2028. That's when those robot builders we were just talking about are scheduled to actually start building things like landing pads and habitats. And all of that hard work paves the way for the 2030s, when the first permanent habitat gets assembled. And just in case you think this is all just some sci-fi fantasy on a PowerPoint slide, check out this number. Over 25,000. That's the number of person-hours that have already been poured into just DARPA's architectural study for this project. This isn't a what-if, folks. The work is already happening. The foundation is being laid as we speak.
So we've talked about the tech, the resources, the whole timeline. But none of it matters without the most important piece of the puzzle, people. And believe it or not, that's where you come in.
Everything we've just talked about, all this amazing technology and incredible planning, it's all leading to the moment when humans will walk on the moon again. But this time, they're going to stay. So my final question is for you. Think about it. Knowing all the risks, all the challenges, but also knowing you'd be a pioneer on a new world. Would you volunteer? Seriously, drop a comment below and let us know.
And that's a wrap for today. If you love digging into the future of space exploration and want to stay on top of humanity's next giant leap, do us a favor and hit that subscribe button for Space Repo. Thanks for hanging out with us.